for the event. But But before the commencement of the events, I would like to express my sincere gratitude to the management of CIT who provided us this wonderful opportunity to be a part of this event, and to the IBM Quantum organization for the extended support throughout.
So now, without further ado, I'd now like to introduce our guest of the day, Dr. L. Venkata Subramaniam sir. Venkata Subramaniam sir here is an experienced leader, a strong researcher, and a recognized inventor in the field of artificial intelligence. He is currently invested in setting up quantum computing as the leading area of research in India. It's an honor to have you here, sir. I kindly request you to take over now.
Thank you so much. So I'm really happy to be here, and I'm excited that youngsters like yourself are getting into quantum in a big way. So so I'm going to tell you about a little bit about what the quantum era is, right? But before we do that, let me share my screen. One second. Okay, are you able to see my screen?
Yes, sir.
Okay, great. So I'm going to start with a small poll. Okay, so to take this poll, you just go to www.menti.com and use this code 58105329. I hope you're able to see the screen. So the question to you is, what do you think of when you hear the word quantum? So just go and type the word that you think of, that comes to your mind when you think about the word, when you hear the word quantum. So it's an online poll. You just have to go to this website mentioned on top and use this code. Okay. Okay, so we have some interesting words like small, mystery, teleportation, physics. Okay, so very interesting. So yes, this is a new area, right? And a lot of us have, just started getting into this area. And that's what's exciting about it. Everybody is starting out at the same level. It's a new technology. So nobody is an expert. Everybody is an expert. And it gives an opportunity for everyone to contribute. So I'm going to, stop this poll now, and let's go back to the presentation now. So I'm going to talk about, how do you prepare yourself for the quantum era? So today, you might know that, the computers, they came out in the 1940s, 1950s. That's when, the classical computers started coming up. And today, quantum computing, well, this is a 2019 picture, but quantum computers have since 2019 advanced a bit. But we are at that stage, where computers were in the 1940s, where it was still diodes and large computers with many moving parts, actually, unlike the electronic computer of today, which, for example, the laptop that you have in front of you. So it took, 60, 70 years to reach here. And quantum computer today, in 2021, is in that stage, in the stage that the computers were in the 1940s. And so this is, this is an opportunity, as I said, for each one of us to get into an emerging area and make contributions there. But the classical computer, it took nearly 50, 60 years for it to become, all prevalent, for all of us to have these laptops in front of us, to start using them. But quantum computers, the interesting thing is that because of cloud computing, each one of us today has access to this quantum computer. So even though the quantum computer is very basic, we still have that access that we can have over the cloud. So this is a question for all of you. This is a cartoon here, but the question is: are quantum computers faster? So this, I'm going to go back to the poll, and I would like you all to vote. This time, please see that the code has changed. So it is 92265631. Can you please vote which computers are faster? Is it quantum computers or is it classical computers? Okay, I see a lot of people voting for the quantum computer. Okay, so I think the majority is going with the quantum computer. Okay, I'm going to go back to the presentation. So all of you, most of you answered that it's the quantum computer which is faster, right? So here is a very simple, um, insight for you. So if you are multiplying two numbers, p into q equal to n, how long does it take to multiply, 2048-bit integers? On a classical computer, this takes 0.0025 seconds. But on a quantum computer, the same multiplication takes 75 seconds. So as you can see, in a multiplication task, which computer wins? The classical computer wins. So on a simple task like multiplication, which we perform, for almost every calculation that we do, a lot of these calculations, multiplication is a basic, operator. And for on that, the classical computers win hands down, right? So they win against the quantum computer by a huge margin. They are much, much faster. But let's say we are trying to do factorization. So we did multiplication, but if we are now given a large prime number, a large integer, and we want to find prime factors for it, this operation on a classical computer is going to cost you 4.7 billion CPU years. And I don't know if you know, Shor's algorithm has shown that the same operation can be done in 8 hours on a quantum computer. So there are operations which are much faster on the classical computer, things like multiplication, which we just saw, but also many other things. For example, the video that you're seeing, the audio that you're hearing from me, a lot of these things will continue to happen on a classical computer. But there are operations like this prime factorization, which is going to happen on the quantum computer, because as you can see, it's going to be much, 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 much faster, right? So what does this mean? This brings us to, one of the topics of the hackathon, which is, cryptography. So as you might be aware, prime factorization is what is used in encryption today. All the encryption that you see on the websites, for example, when you do your uh, bank transactions or your WhatsApp chat, that is all encrypted using the fact that prime factorization cannot be done on a classical computer in a reasonable amount of time. But when quantum computers become powerful enough, there will be a time when all the encryption schemes that we have today are going to break, and we're not going to be able to use the encryption that we use today. All the data is going to become unsafe. So at that point of time, all of us will have to look for new encryption schemes, and people have already started looking. And I guess the purpose of today's hackathon is also to make sure that you are aware of this fact that current encryption schemes on classical computers, the classical algorithms for encryption, are breakable using quantum computers. And it is for us to figure out how do we come up with new quantum encryption schemes which are powerful enough that they cannot be broken by quantum computers. So this is an interesting one. Richard Feynman said, how well do you understand quantum? And he's considered like the father of quantum. And he said, nobody understands quantum mechanics. So that's why I told you in the beginning that all of us have this opportunity today, that here is a technology nobody deeply understands. So here is an opportunity for you to start contributing. Everybody is starting out on the starting line today. Nobody is ahead of anybody else. So all of us have this opportunity to contribute to this new and emerging area of science. So this, I guess, I don't need to go into this much, because I assume you're all aware of what is quantum and what are quantum circuits. So you have to build these quantum circuits and run these gates, and this is how you program quantum computers, by writing quantum circuits, right? uh, so here is another cartoon. So it quantum computing uses two very basic principles. One is superposition, which means that your qubit can remain in multiple states at the same time. And the second one is entanglement, something that Einstein called spooky action, which means that two qubits, no matter how far apart they are, whether one is in this room and the other is in another room, or one is in this corner of the universe and the other one is in the other corner of the universe, they still can be entangled, which means they can be correlated. And this is something, again, that Einstein never understood how it's possible. So, but these are the principles that we use in quantum computing, right? And what is quantum computing good for? We just saw that for multiplication, classical computers are better. But for prime factorization, quantum computers are better. So there are several things, like modeling nature, things like molecular interactions. These can never be done on a classical computer. Why? Because these are quantum mechanical phenomena. They are at the subatomic level, and they are following the laws of quantum mechanics. And as a result, quantum computers can easily simulate these things. CERN, the you would have heard about the Large Hadron Collider in Europe. I think 27 kilometers or something, this large ring where they conduct a lot of these physics experiments on small particles. So even there, a lot of those experiments can be simulated on a quantum computer. We just saw, algorithms like, prime factorization, which is Shor's algorithm, can be performed much, much faster on a classical computer, on a quantum computer. And then things like optimization, machine learning, search, a lot of these things can be done much, much better on a quantum computer. And cryptography, just a primer, all of us know, as I told you, it's based on prime factorization, but here is Shor's algorithm that can break it. So as a result, people are now looking for new schemes of encryption. So cryptography is changing, right? So what does that mean? The crypto clock is counting down, which means that as soon as quantum computers become powerful enough, there is going to be a time when all the current encryption schemes will be broken, and we need to look for new encryption schemes. So Peter Shor, who wrote this, who wrote the Shor's algorithm for prime factorization, here is a poem he wrote. If computers that you build are quantum, then spies everywhere will want them. Our codes will all fail, and they'll read your email till we get crypto that's quantum and quantum. So everything, email, WhatsApp, bank transactions, all of that is going to fail. And I'm really happy that, the hackathon has cryptography as a theme, because this is a very, very important, scientific breakthrough to be able to find these crypto algorithms which are quantum safe, right? And that's what, in this hackathon you're about to do, right? So what are the other applications? What are the other applications of quantum? So there are several potential use cases, right? So there is option pricing. There is, in finance, there are a bunch of things that people have started doing with quantum. Then in chemistry, in materials. So as I said, you can easily simulate uh, molecules in quantum computers, which means that, things like new drugs, which is new medicines, new battery materials, protein folding, antibiotics, new fertilizers, all of these are possible using quantum computers, right? Because you're able to simulate things at the molecular level. Logistics and optimization. I don't know if you've seen, the government has announced something called the Gati Shakti. What is that about? How do you optimize everything? You want to move goods from Delhi to Chennai. How do you move it? What is the best route? What is the best, given the cost and the various parameters, how do you move it? So these are things which can be done much, much better using quantum computers, right? So I'm going to, go back to a poll here. So let's again, so are there any questions before that? Anything that you want to ask? Any questions anybody wants to ask?
Participants, if you have any questions, please put it in the chat box.
Okay, sure. So let's move on. So what's the next question? So what are the top skills required to be a quantum engineer or a quantum scientist? So what do you think you need to pick up to become a good quantum scientist or a quantum engineer? So all of you are engineers at CIT, and uh, you know you can contribute to this area, right? So we just saw that everybody, there is no expert in this area. Each one of us is an expert. It's a beginning area, it's a new area. But what are the skills that you need to be able to succeed? So we have somebody saying mathematics. Yeah, very interesting. So, a lot of people going with maths, coding, problem solving, solving problems, creativity, patience, study at molecular level, reasoning. Okay, so very interesting. So yeah, so you need all of these, and you don't need any of this also. Even if you don't have any skill today, you can still get into this area. And that's what, as I said, Feynman himself said, there are no, nobody understands quantum mechanics. So here is an opportunity for each one of you to actually pick up any simple skill that you want to be part of this quantum and start contributing, right? So this is an area which is wide open. It's a new area that's beginning, and each person can contribute. So I'll go back to the presentation. So let's look at some of the applications, right? So here is, Daimler and IBM, they've been looking at using quantum to come up with new materials, right? So new materials for batteries. Why batteries? We use it in our phones, we use it in our laptops. There are now these battery driven cars which are coming up. We want to store solar energy. So how do you store that? You store that in a battery. So battery technology is becoming very, very important for humanity. With all this global warming and everything happening, people want to move away from using fossil fuels like petrol, like coal, all of these, and they want to move to green energy. And green energy is, catching solar energy in solar cells and putting it into the battery and trying to use that for charging our phones, to charge our laptops, to light our bulbs. So all of these things, it's very important that we look for materials. And as we saw, materials means chemistry, that means molecular interactions, and that means quantum computers are ideal for that. Why? Because quantum computers use quantum principles to do the computation. And what is happening in materials? It is molecules which are interacting with each other. And the same thing, materials can be extended to medicines, because medicines are also uh, molecular interactions, between our, let's say for COVID, it's between things, proteins in your lungs interacting with the COVID molecules, right? The COVID proteins. So all of these are molecular interactions done very well using quantum computers. And ExxonMobil and another energy company, again they're using quantum computers to do their simulations. And here is a different one, finance is, all machine learning, optimization, and all of that again is very well done on quantum computers. So there are a class of problems, the easy problems, like we saw multiplication. Multiplication beautifully done using classical computers, right? But there are hard problems, things like factorization, which we just saw, prime factorization, and that's not done very well on a classical computer. But this dark blue box here at the intersection of the light blue is classical computers, dark blue is quantum computers. So there are a class of problems which can be done very well on classical, but there are other classes which can be done much better, much faster on quantum computers, like factorization, like chemistry, materials. And there are, things that can never be done on classical computers, even in a billion years. At least factorization, we saw it can be done in a 4.7 or some X number of billion years. But there are, simulating quantum mechanics, for example, things that CERN is interested in, that can never ever be done on a classical computer, but that can be done on a quantum computer. So this is an important figure, because this is, you are in 2021 this year. Later this year, IBM is going to come out with the 127 qubit quantum processor, the Eagle processor. 2022 433, 2023 it's going to cross 1000 qubits. And what does that mean? That means that, by 2023 there'll be powerful enough quantum computers that you here, you people who are about to graduate and who are still in college, you will have an opportunity to work on computers as soon as you graduate, as soon as you come out of your education, to work on a quantum computer which is powerful enough to do something useful, right? And that's not very far away. It's only 2 years away, right? So, and that's very exciting, because you students are now getting into this field. Nobody is an expert. All of us are picking up the skills, and here is a computer that's going to come up in 2 years, that's going to help drive this forward. And that's an opportunity for you. The other term, you should look this up, quantum volume. So I don't know how many of you have you heard about Moore's law. So Moore's law said that every 2 years the classical computer doubles in its power, right? It's doubling every 2 years. The new Moore's law is the quantum volume for quantum computers. We know that Moore's law is slowing down now because of the miniaturization has reached a level where the quantum mechanics is changing things, and that's where quantum computers come in, and quantum volume has been doubling every year, right? So every year quantum volume has been doubling, and what that means is this is an exponential growth, and we are going to see quantum computers powerful enough to do certain things. But are quantum computers powerful enough to do anything better than classical computers today? The answer is no. Yes, Google has shown certain things, like they've shown some quantum supremacy on a very narrow problem, but on a larger class of problems, we are still at a point where classical computers are much better on most tasks. And that's why it's very important that 2023, when we reach that 1000 plus, it is expected that we will have applications where we might do much better than on classical computers. So any questions so far? Okay, I'll keep moving. So quantum computing is a truly interdisciplinary field. Okay, so it's an area where you need people from physics, you need people from chemistry, maths, computer science, electrical, mechanical, materials, and a lot of you mentioned things like coding, physics, things like molecular interactions, understanding molecular dynamics. So there are many things that you can do, and often you don't even have to know the physics. So what is entanglement? What is superposition? If you don't even need to know that, because there are several libraries which are available today, which you can just start using. You don't need to know the physics of anything, and you can just pick up things along the way. Chemistry, like we talked about molecular interactions, so that's all chemistry. So if you're good at chemistry, here is an opportunity. If you're not, you can still do many things in quantum computing, right? So there are several things which are out there at the algorithm level, at the circuit building level, at the coding level. And there are, just like today, you can use a classical computer without knowing what is going on inside your laptop. You can still use it. There will be a time when you can use quantum computing in the same way. And in fact, that's not very far away, because there are already several libraries available, right? So there are all these programming languages like Qiskit and several others, and most of them are Python based, right? So Python is a programming language which many of us are very familiar with, and all of these quantum languages are Python based, so it's very easy to pick them up. You can start coding very, very easily. There is a open source textbook, and I'm very happy, Manjula ma'am and the a lot of you have worked on the localization efforts to make Qiskit available in Tamil, and we're trying to do it in several other Indian and other languages also. But what's interesting is that here is an open source textbook along with an open source coding language that you can contribute to, that you can, pick up very easily and start coding, right? So you can access quantum computers over the cloud, and you can start programming, right? Here, you start using the examples which are given in Qiskit, and you can very easily get into programming quantum computers. And like I told you, there are several libraries which are available. There is the machine learning library, there is the nature library, there is the finance one, there is the optimization one. And all of these allow you to very easily pick up these libraries and start coding, right? Doing simple applications, right? So it's not at all hard. If you know Python, you can start with the examples in the Qiskit textbook, and it's not hard. Each one of us can easily go in there and start. And you don't have to be an expert. You can start at the basic level, and all of us, we have a learning curve, right? And that's that learning curve. You just have to start. That's all you have to do. And there are several, badges and things that you can earn along the way. So one is, of course, there is this Qiskit developer certification. There is also the Qiskit advocate, which is, to become a Qiskit advocate, you need to be an expert, which, for example, Manjula ma'am is. So but there is a starting point. You need to start. There are several open source courses out there. We just offered one on NPTEL. All that course material is available on NPTEL. IBM offers these summer schools. Last year there was one, this year there was one, and each one of these has, free lectures available that you can do. But don't just listen to the lectures. Start hands-on work. Okay, start the labs, do the coding. That's the best way for you to learn. So the software, as we saw, there are several layers here. You can be a kernel developer if you are very good at the physics and the, the superposition, the entanglement, all of those things. If you understand it well, you can actually start at that level, which is, the kernel development. But, there are also algorithms, people like Shor's algorithm, like Grover's algorithm. These people didn't have a quantum computer. They were mathematicians basically, and they came up with these algorithms to do things much, much faster by exploiting quantum mechanics. And then if you don't understand the algorithms, you don't understand any of the physics, you can become a model developer also. Like I showed you, there are all these model services like finance, optimization, all these libraries are available. You can just start picking up those libraries and build use cases. Take some data, take some code which is already built up there, and run it on that. And that's it. You'll see the difference, right? So there are many things that you can do, and today, we are at 2021. This is called the noisy intermediate state quantum. No, quantum machines today are very noisy, in the near future, we expect them to start becoming fault tolerant. The classical computers, the laptop you're using, these are fault tolerant. You type a K, it doesn't become anything else. It remains a K. Whereas on a quantum computer, there are many things that come into play, like interference. I mean, there are coherence and other things which happen. And that means that there is noise affects quantum computers. So that's an active area of research. And but there are still things that we are showing with this noisy NISC computers, right? There are still things that we are developing, and we have shown that there are things you can do with quantum computers, right? So as we saw, there are certain things that classical computers do much better, like simple multiplication. So classical computers are not going to go away anywhere. Quantum plus high performance computing plus cloud, which means things like GPU, CPU, and QPU, they are going to come together. You're going to see more and more applications where classical and quantum are going to come together to solve problems, right? So you're going to see this in the next few years. You'll see some part of your process will run on a classical computer, some of it will run on a quantum computer, and then you'll put together the results, and that's how it's going to run, right? So quantum, AI, cloud, all of this is coming together now to solve some of the tough problems. What are the tough problems? We just talked about energy, finance, molecular simulation, drug discovery. So all of these are going to get a shot in the arm as they become much more solvable using this combination of quantum, AI, and cloud. This is the other very interesting development, which is that the Indian government has announced that they are going to leverage quantum in a big way. They are investing 8,000 crores towards the national mission on quantum technologies and applications. The government wants India to become a quantum driven economy, right? So as we saw in the 1940s, the classical computers happened. uh, the first computer came to IIT Kanpur in 1963, the IBM computer, 1963. Several courses were run in IIT Kanpur. Narayan Murthy, FC Kohli, a lot of these people used those first computers in IIT Kanpur, right? So, and that's how they became computer literate, and they built these companies like TCS, Infosys. A lot of this happened because of those early efforts, right? And that's why I'm really happy that Manjula ma'am, you and the team here is putting this effort, because in the quantum era, if the first computer IIT Kanpur 1963, 2024 India will have the largest number of software engineers. How many years did it take? 70 years. In quantum, we don't want it to take 70 years for India to become a quantum power house. And that's why it's very important that youngsters like yourself get into this area, start contributing. And we need that in quantum, we don't take 70 years to become a powerhouse, but we do it much faster. So the quantum era is here. Gartner survey, 44% of companies believe that in the next 3 to 5 years, they're going to see impact from quantum computing in their businesses. There are plenty of quantum jobs which are getting, listed on LinkedIn, all over the place. IBM is hiring, Infosys is hiring, TCS is hiring, Amazon is hiring, a lot of companies are hiring people with quantum skills. So as we saw, the integration of quantum computing, AI, and classical is going to build these, multi uh, cloud workflows. And we're going to see that, in the next computer revolution, which is going to be a quantum powered one, we're going to see a lot of, substantially hard problems getting solved. And Nobel laureate Bill Phillips said that using quantum principles to compute is as different from classical computing as a classical supercomputer is from an abacus, right? So the quantum computer, as we saw, uses quantum principles. So it's very, very different from a classical computer, right? And that's where its power is coming from. So that's why, you're able to use a quantum computer to solve some of these very, very tough problems. And that's why, you need to get into this area. You're just beginning your career. And as I said, India is investing in a big way into quantum, and the government does not want that, it takes us 70 years to become leaders in quantum, like it took in classical. We want to lead from day one, and that's why it's important that, youngsters like yourself get into this field and start contributing right away. uh, so I'll end here with just one more poll. uh, okay, so when do you expect that you'll see quantum computers become faster, better, or cheaper than classical computers? You think it's going to happen in the next 5 years, next 10 years, or next 20 years? So here is a question for you. Um, okay, I see people going for 10 years. Okay, interesting. So, well, we saw, now it looks like, the next 5 years is sort of leading. Okay, very interesting. So this number of years is really in your hands. Okay, it's in your hands, because you are the people who are going to drive the quantum era. You are the people who are going to build these algorithms, these code, and you're going to solve some of the tough problems. So whether it's 5 years, whether it's 3 years, whether it's 2 years, or whether it is 30 years or 70 years, is really up to you. You, the youngsters of today, this is a question that you have to answer, that you have to contribute. As I said, the government is very, very keen that each one of you participates and contributes to making India a superpower in the quantum era. So, with that, I'm going to stop. So, thanks a lot for listening. Uh, Thank you very much.
Uh, Thanks a lot, sir. I would like to express my gratitude to you on behalf of our management, our principal, and the faculty members and all the participants. It was really a very good, motivating session for our students. Thank you so much, sir. I request participants to ask to have any doubts. If you want, you can ask with us, sir. So, what is your suggestion? What skills you want our students to have?
Yeah, so see, most of you, I guess, are engineering students, right? So engineers are good at programming, because you would have anyway picked that up as part of your skills. um, Physics, if you're good at it, pick it up. So and actually just be hands on. That's the most important thing. Just go and start coding. Like in the 1960s, Narayan Murthy, FC Kohli, they all had to go physically to IIT Kanpur, go to that AC room and run their code. There was only one computer, so they had to do timeshare. They had to fight amongst themselves to say, I'm going to use it now, you're going to use it now. And that's something you don't have to do. Each one of you has that access over the cloud. So you're a lucky generation, and it's really up to you to just start. Because quantum computing, for as Feynman said, nobody understands it, and so as a result everybody understands it also. Whatever understanding you have, you can jump in with the open source code which is available, open source computers which are available. And so the skills, just pick up a little bit of basic Python, pick up a little bit of maths, because you need to understand how do you the algorithms that are there. And then it's all trial and error. Just go and put some real data into the system and run your code, and you will learn. You learn much faster that way.
Thank you, sir.
So which year are most of you from? So are you all from
We
like
have from second years to final years.
second year? Okay.
We have from every branch,
Okay.
from all the branches.
Yeah, so please feel free to connect with me. I'm also happy to help you with anything. So we have several projects at any given time that are ongoing. So in finance, in chemistry, materials, all these areas. And as I said, there are also numerous job opportunities around the world. There are also several masters and PhD programs which have been started across the world, including in India. So any of you wants to get into further studies, wants to get into a job in quantum, so all these things are open. So as I said, the only requirement is that you be hands-on, you start actual coding and you start actual work.
Thank you, sir.
Okay, thanks a lot.
If no more questions, Sharon, please take over.
Participants, if you have any more questions, please look up in the chat box. I guess no questions. Thank you so much, sir, for sparing your valuable time for us and empowering us with your knowledge. Thank you so much, sir. And I also like to thank our principal, the heads of the departments, and all the faculty who have given us this opportunity to be in this meet and uh, attend such a wonderful session. Um, Also, thank you participants for connecting. And an information to the participants, if you have any concerns regarding this event or further events, please let us know. The email will be dropped in the chat box. It's also available on Discord or Hype. You can also join us on Hype, on Discord. There is a general support channel. So we are all there to help you out. Also, to the participants, please make sure that you log in using your registered mail ID so that all the information is shared through the mail. Um, so yes, guys, please stay active on Discord, and all the announcements are going to be posted there. So thank you for connecting and have a great day ahead.
Thank you, sir.